Hello everyone. In this video I am going to demonstrate Allen Bradley PLC panel. So you can see here this is an Allen Bradley rack. So this is the power supply of the rack. This is the CPU. This is the control net card. This is the redundancy module. You can see here this is the CPU. This is the CPU. This is the control net card. This is the redundancy module. So this module is responsible for redundancy with another rack. You can see here there are two racks. This is one rack, this is another rack. So this rack is the primary rack. You can see here prime, PRIM, prime. This is the primary rack. And this is the sync rack, secondary rack, synchronized rack. You can see this is sync. So this is the primary rack and this is the sync rack, synchronized rack, secondary rack you can say also. So you can see here there is a optical fiber cable. You can see an optical fiber connection coming from here, and the same optical fiber connection terminates here. See this optical fiber connection from the redundancy module is connected to this part, and this is the control net network responsible for the communication with the modules. You can see there are two wires, there are two coaxial cables. These two coaxial cables are used to communicate with the other processors. Same thing on the primary rack, you will see there are two coaxial cables and they are used to communicate with the IO modules, the IO racks. And this is the processor. Here also on the secondary rack you can see there is a processor. So both the racks basically they will be having one processor. As you can see here, this processor is in run mode. And here also you can see this processor is in run mode. We can put it in remote mode and we can put it in program mode. When we are putting it program mode, we are going to program this PLC. And when we are keeping it on run mode, it will execute the instructions. It will not allow us to program it. It will only execute the instruction. For safety reasons, we are keeping it in run mode so that no one can remotely change the program. That's why usually we are keeping it in run mode. We can keep it in remote mode and we can select the mode from the laptop also. Now as you can see on the PLC, there is a battery. This battery is responsible for keeping the program memory intact. Inside the PLC there is a RAM. So this battery is responsible to keep the RAM healthy. And this is the communication port. With this port we connect the laptop and we are communicating to the PLC. You can see with this port we are connecting the serial port and we are connecting to serial device and we are programming the PLC. You can see here this is the port definition written here. The pin configuration is written here. So this is what the PLC looks like. So this is Logix 5555 family CPU. And here there is a control net card. You can see this is a control net card. This is the control net card. And from here also we can connect control net connection to the laptop directly to diagnose the control net with this port. This is not an Ethernet port. This is control net port only. And from here if we can connect to our laptop to diagnose the control net module. And here you can see these are the coaxial cable lines. These lines are connected to the IO modules. Now I will take you to the IO rack. So this is the PLC primary rack. This is the PLC secondary rack or synced rack. So now I am going to take you to the IO rack. So before going to the IO rack, these are the power supplies for the IO rack. You can see these are the power supplies for the IO rack. So presently this power supply is not in a good shape. You can see the power LED is not present. Okay, so these are the power supplies for the racks. Now I am going to take you to the IO racks. Now as you can see, this is the IO rack. This is the IO rack. You can see the first module. This is the control net module. On the PLC rack also you have seen one control net module. So this is the same control net module. The cables from the control net modules are coming to this card. On the downside of this card you can see the same coaxial cable connections. The same coaxial cable connections are there. These coaxial cable connections are responsible for sending and receiving data to the PLC. These coaxial cable connections are responsible for sending and receiving data to the PLC. Now after this rack, after the control net rack, we can see there is Ethernet IP rack, Ethernet rack. You can see the IP address of the Ethernet module. The card is OK. 192.168.0.116. This is the Ethernet IP address of this card. You can see the link is active. Okay, it is displaying the IP address, and below you can see the LAN cable, the Ethernet cable. This is the LAN cable, Ethernet cable. This card is responsible to communicate this PLC to the engineering station. We cannot communicate, or we are not communicating nowadays with the engineering station using control net. Rather, we are using Ethernet card to communicate with the engineering station. So this is how the Ethernet card looks like. So this is how the Ethernet card looks like. So after the Ethernet card comes the relay output card. This is the output card giving commands, digital signals to the field instruments. You can see there is an OK indication on the card, and the pin number and the output 14 is active presently. You can see the output 14 is presently active. And this is the wiring of the card. You can see how the wires are connected on the card. You can see how the wires are connected on the card. After that, there is one more relay output card. This is the output card giving command to the field instruments, to the solenoids. The digital output commands this card is giving. See, channel 0 is on, channel 1 is on, channel 2 is on, channel 4 is on, and channel 10 is on. And the card is in healthy status, OK status. After that, this is a binary input card, digital input card. This card is going to scan the field instrument status, the digital input instrument status. Here also you can see channel 1 is on, 3 is on, 4 is on, 5, 6, 7, these are on. Okay, then channel 13 is on, channel 14 is on, channel 18, 19, 16, 21, 22, 23, 24, 25, 26, 28, 29. All these channels are on this DC input card. This is a binary input card. So this is the wiring of the binary input card. You can see this is how it is wired. You can see how this is wired. This is dressing. Like all the cables are dressed nicely, very nicely they are dressed. So this is how this card should be wired. This is another digital input card, same function. This is special card called metering card. This is special card called metering card. I am not going to discuss this card in this video. In the other videos, this is a advanced subject. So in this video, this is a basic topic. So I will not discuss this card in this video. I will make a separate video for these cards. So after this card, this is analog input card. You can see this is analog input card. All the analog signals like pressure transmitters, positioners, all feedbacks, analog input signals are coming to this card. You can see the wiring. So this is the wiring of the card. So this is the analog input card. Same way there is one more analog input card. Okay, the card is in OK status. See, the card is OK. The card is in OK condition. So there is one more card, analog output card. You can see this card is giving command to the field. You can see it is giving analog command to the field. See the symbol. See the analog input symbol. It is getting commands from the field, and this card is giving commands to the field. See. So the wiring of the analog output card, the terminal strip I am going to show you. So this is how this card looks like. You can see this is how this card looks like. Analog output card looks like this. See how it is wired. So this is the wiring. Now I am going to show you the RTD input card. This is the resistance input card. This is a resistance input card. This is another kind of input card. This is not going to take 4 to 20 milliamps input. Rather, it will take RTD input. Direct temperature inputs this card will scan. All the temperature inputs this card is going to scan. This is RTD card. Resistance temperature detection card. Okay, this card is mainly responsible for reading the temperatures. So I am going to show you how the card wiring looks like. So this is the terminal strip. So the terminal strip looks like this. You can see this is how it looks like. So this is all about the first rack. You can see these are the slot fillers. There is no card in these 3 fillers. Okay. So this is the far view of the card of the rack. So from the PLC, then power supply, then this first rack. After this there is one more rack, second rack. This is here also all the field instruments are connected. Same way you can see here there is a control net card. The control net card is reading all the field devices and giving commands to all the cards. It is reading and writing to the field instruments, this card. Actually this card is communicating to the PLC and it is giving all the status of this rack to the PLC. You can see in the same way there are 2 coaxial cables. These 2 coaxial cables are connected to the CPU. You can see here this line. See, these 2 lines are going to the CPU. See, from here now the wires are coming and they are connected to the control net card. You can see from here from these 2 Y repeaters the wires are connected to the control net card. And you can see here this card is going further down. The cables are going further down. It is going to connect to some other devices. So now on this rack you can see same way this is the relay output. Again relay output, binary input, digital in DC input, DC input. This card is thermocouple input card. You can see this is thermocouple millivolt input card. This is the thermocouple temperature monitoring card, temperature reading card. Okay, this card can read the temperature directly. The card is in OK status and the wiring I am going to show you. This terminal is not coming out. This is very hard, so I will not try much now. So this is the card. The wiring is same like other cards. So this is a thermocouple input card. Same way again thermocouple input card, thermocouple input, thermocouple input, thermocouple TC input, thermocouple input. You can see thermocouple input, thermocouple input, thermocouple input, RTD input. It's resistance input. So all these cards are responsible for measuring temperatures. This temperature thermocouple, temperature thermocouple, 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 all are thermocouple, and this is RTD. So all the cards colored in brown, they are responsible for measuring temperatures. See, this is like a color code. And digital input color code is blue. Relay output color code is orange. Same way analog output color code is olive green. Analog input color code is brown. RTD input color code is brown. Digital input color code is blue. Relay output color code is orange. So this is the far view of the second rack. So you can see CPU, power supply distribution area, first rack and the second rack. After this you can see again there is a power supply distribution area. These power supplies are giving power to the field instruments. All the field instruments are getting power from these power supplies. Now this is the network switch. This is Ethernet switch, network switch. So here you can see there is a LAN cable connected. This is the LAN cable connected. Ethernet cable is connected here, and from here optical fiber cables are coming out. So this Ethernet switch is connecting this panel to some remote panel or to the engineering station. So here you can see this Ethernet port is connected. You can see the card is blinking. The ports are all blinking. So this is the power supply. And here you can see the LEDs, all LEDs that is communicating with the remote server. And these are the optical fiber connections. You can see the optical fiber connections. These are going to the remote server. You can see. And these are the empty ports. These are all empty ports. These are not connected, not used. So like that, like this, it is communicating to the remote equipment. You can see. So now I am going to show you the field instrumentation. So see, this is the field terminal. So field instruments are coming on this side, and from here it is going to the card. You can see from here it is coming in, and from here it is going out. Just have a look on the field instrumentation. These are the thermocouple inputs. These are the thermocouple connections. You can see thermocouple symbol is there. You can see nickel chromium and nickel, type K type thermocouple. Okay. So these are coming in pairs. Okay, one sensor with 2 screws. See, one sensor with 2 screws, like that. And here you can see these are the binary instruments, binary data. You can see knife edge terminal blocks are there. Here also you can see field instrumentation wires. Here also you can see field instrumentation wires. And here you can see the control net ends. On 5A, 5B, the control net network ends. Okay. Here you can see there are dead plugs. There are end connectors. So we cannot keep the control net network open. So here we have connected the end connectors. See the control net networks coming here. And it is directly coming to the PLC finally. See, it is coming to the PLC finally. And here also you can see when it comes to the PLC, here also there are end connectors. See, these two are the end connectors. So finally it is getting terminated over here. So this is how Allen Bradley PLC system, PLC panel is wired. So this is the basic wiring diagram of an electrical panel with Allen Bradley PLC Logix 555 CPU in action. Thanks a lot. Thanks for watching.